Right, so we're going to get in more practice factoring trinomials of the form ax squared plus bx plus c. Sometimes a is just the number 1, in which case it just looks like x squared. But sometimes a can be a different number. Like on this third one here, a is 3. You know, it doesn't just start off with a y squared, it starts off with a 3y squared. So if a is 1, like it is for examples 1 and 2, you can just sort of do, the normal thing, just sort of make the x and pick your two numbers. Whereas if a is some other number, like 3 or, like in this case 6, or 2, or 16, or 6, that's when you have to slide and divide. And that's just the same process as normal, is just before, in the beginning, you take that first number and you slide it to the back. And at the end, after you choose your two numbers, you divide by that same number. So there are only two extra things to do, and those two extra things are to slide and divide. And that's if your trinomial starts off with a constant or a coefficient other than 1. Okay. So here you're going to be looking for two numbers that multiply to 6, multiply to positive 6, and add up to positive 5. What two numbers can you think of that multiply to positive 6 but add up to positive 5? Now, considering negative 1 and negative 6, those definitely multiply to positive 6, yes, but they add up to negative 7. Yeah, and even if you switch the sign of one of them to where they're like 6 and negative 1, now they add up to 5, but they don't multiply to positive 6 anymore. Now they multiply to negative 6. So your two numbers have to be something else, and in this case they are positive 2 and positive 3. Yeah, the ones involving 5, 6, and 1 are tricky because depending, even just like one of the signs being a little bit different can change it from, the answer from being like 2 and 3 to 1 and 6. Okay, so what are your two factors then, since this is just a regular trinomial?
X plus 2 and x plus 3.
Yeah. Okay, there you go. Okay, this is an interesting one. Can anyone think of two numbers that multiply to negative 10 and yet add up to, this is just x, so the coefficient that's implied to be there is a 1. Can anyone think of two numbers that multiply to negative 10 and add up to 1?
No.
Yeah, me neither.
So would this one be like, what is it called? Prime?
Yeah. Meaning, not factorable. It can be broken down into factors. Very similar to how a prime number can be broken up into, two distinct factors. All right, so we got one that has a 3 in the front of the y squared. So we got to take that 3, slide it to the back. And what trinomial is that going to give us? Okay. So we'll work with that. Want to find two numbers that multiply to negative 18 and add up to negative 7. Now there is it's not always just guesswork getting these two numbers. There is some amount of sense, mathematical sense that you can use in trying to find these two numbers. So if you look at these numbers right here, you want to find two numbers that multiply to -18. If you have two numbers and they multiply to a negative number, that means one must be positive and one must be negative. Okay, so one positive, one negative. Okay. Now, they also add up to a negative number. So you know that you have a positive number and a negative number. If they add up to -7, which one's bigger in magnitude? The negative number you're going to have or the positive number you're going to have? Yeah, the negative number, because when you smush them together, it comes out to -7. So you're looking for a positive number that's maybe sort of small, and a negative number that is maybe sort of bigger in magnitude. Does anyone have any idea what those two numbers might be? Okay, -9 and +2. Got to leave space underneath because we got to, this is a slide and divide problem. Okay, so those are our two numbers, -9 and +2. Those multiply to -18 and add up to -7. But we got to divide. Divide by what? That 3 that we slid. Okay. Now, and we got to reduce these if possible. Does +2/3 reduce? No, and it's going to be one of those factors with the coefficient in front of the x. However, does -9/3 reduce? Yeah, it's going to reduce to -3, and we're going to get to use that -3 sort of all by itself. Okay, so one of your factors is x minus 3, and that comes from this -3 that that came out of this reducing. It is y, yeah, that's absolutely correct. It is y minus 3. Okay, your other factor that comes from this +2/3, this doesn't reduce, so we got to take the bottom number, put it next to the variable. So this 3y. And then what goes after the 3y? +2. Okay, number 4 is another slide and divide. We'll take that 6 that's in front, slide it to the back. And what trinomial is that going to give us? Okay. So we just want two numbers that multiply to 30 and add up to 31. Probably won't have to stretch your brains too much for this one. What two numbers can you think of that multiply to 30 but would add up to 31?
30 and 1.
Yeah. This is a slide and divide problem, so make sure to leave some space underneath. The +30 and the +1. Okay. So now that we have our numbers, 30 and 1, we're going to divide by whatever the original number was that we slid. So we're going to divide by 6. And does 1/6 reduce?
No.
No. That'll just have to be what it is, or we'll just have to use that sort of as it is. Does 30/6 reduce though?
5.
Yeah, it becomes +5. Okay, so one of your factors, what is one of your factors?
X plus 5.
X plus 5, and then what's the other factor?
6x plus 1.
Correct. Right, and that's the one that comes from this 1/6. Take the bottom number, put it next to your variable, then just tack on whatever number you have on the top here, which is plus 1. Cool. Cool. How's everyone feeling about trinomials so far? Like, do you feel comfortable with them? Do you not like them, but you can do them? Or do you have a real burning passion and enthusiasm for trinomials? Okay.
I understand it. You just gotta do a little bit more thinking of what it goes. I think that's the hard part.
Yeah, I think, right. The easily the most difficult part to any of this is finding the two numbers. That's really the only thing that's really different with every question. Okay, then there are 4 more of these, all of which are, sort of slide and divide trinomials, and then we'll move on to something else. Something that is actually very easy. All right, take this 2, slide it. That gives you x squared minus 15x plus 14. Multiply to 14, add up to negative 15. Interesting. What 2 numbers might those be? And yeah, negative 1 and negative 14. Those will multiply to positive 14. Yes, they will, and they will add up to negative 15. But we got to divide by this 2. Yeah, so this negative 14 over 2 will reduce to negative 7, meaning that one of your factors is x minus 7.
X minus 1.
Yeah. Okay, take the 16, move it to the back, or slide it to the back. Oops. Yeah, right. So x squared minus 8x plus 16. 2 numbers that multiply to 16 but add up to negative 8. Negative 4 and both negative 4, right? So, negative 4 and negative 4. That will multiply to positive 16 and yet add up to negative 8. And you can verify that if you want just by just doing, 16 divided by x divided by x. And then just checking, like, which of these pairs adds up to negative 8. And you'll see that there is the one pair that's right here, negative 4 and negative 4. That adds up to negative 8. None of the other pairs do. Okay. But you're going to take this and you're going to divide it by this 16 that you slid. Yeah, so negative 4 over 16 does reduce. Both of these reduce to negative 1/4. They don't reduce completely to like a whole number, but they do reduce, and you do have to, do that. Okay, same thing with this one. It reduces to negative 1/4. Okay, so they don't reduce completely to a whole number, but they do reduce. And now that they've reduced to negative 1/4, what factor is that going to look like?
4x minus 1.
Mm-hmm. And same with the other one, 4x minus 1. Okay. Almost done. Now I'm going to multiply this 6 right here. It's weird. There's a b squared on it. And all that means is that what your factors are going to be is it's going to be some number like plus some other number of b's. You know, instead of just being like, instead of your factors just having a, your terms are going to have, or your factors are going to have some number of a's and some number of b's as their terms. Don't worry too much about it right now. Just worry about the numbers for right now. Okay. So that's going to give a squared plus 11ab. Again, don't be too concerned about the a's and the b's. Plus 30 b squared. Okay. But the 11 and the 30 are what matter right now. Okay, so you want them to multiply to 30 and add up to 11, these two numbers. If you think of two numbers that multiply to 30, yet add up to 11. Okay, positive 6 and positive 5. Now divide by whatever number you slid in the first place. So you're going to divide by 6. Okay. Does 5 over 6 reduce? No. So we'll use that one as is. Does 6 over 6 reduce? Yes. Plus 1. Okay, so now your two factors are, this plus 1 is going to give you a, so normally, you know, without this a, b business, you might just think, oh, okay, well, it's a plus 1 is your factor. The fact that the b is here on the middle term and on the back term just means it's like a plus 1 b. And that this other factor is 6a. And instead of just a plain old plus 5, it's a plus 5 b. Right, so, you know.
How did you get that?
Yeah, why don't you use the 6 instead of the 30? That's right.
How did you get a plus 1b? Where did the b come from?
The fact that there's a b squared at the end, right? So if your trinomial starts off with an a squared, you know that there's an a in the front of each of your factors. Since it ends with a b squared, by the sort of the same reasoning, you can bet that there's a b at the back of each of those factors.
Okay.
So it's, so just pretend, so if this were just, you know, if there were no b's here, if it were just like this looks very normal, right? A squared plus 11a plus 30. That would have ended up with a plus 1 and 6a plus 5. That looks normal, right? But just because there is that b squared at the end, you know that these terms have to end in a b, so that these, you know, instead of just a plain plus 1 and a plain plus 5, it's a plus 1b and a plus 5b.
Okay.
These are pretty rare. I say that, and then there's, you know, another one. Okay, so 5x squared plus 9xy plus 4y squared. So they start with an x squared, meaning that your factors are going to have x's in the front of each factor. What is going to be in the back of each factor that you can sort of tell because there's that y squared there? Y. So each factor is going to contain an x in the front and a y in the back. And you're just trying to figure out what those coefficients for those are supposed to be. So you can actually already write that your factors are going to be of the form x and then y and then x and then y, and then you're just trying to figure out what numbers go in front here. Okay, take this 5, slide it to the back. That's going to give you x squared plus 9xy plus 20y squared. Yeah. Okay, so the two numbers you're concerned with are this 20 and this 9. Now you want them to multiply to 20 and add up to 9.
So 5 and 4?
Yeah, plus 5 and plus 4. And you're going to divide by whatever number you slid in the beginning, which was 5. Okay, 4 over 5 will not reduce. 5 plus 5 over 5 will reduce to plus 1. So one of your factors is x plus 1y. You can also just say x plus y. Your other factor is 5x plus this 4y. Okay, so that's the extra practice with trinomials that we're going to get today. Okay. Is it alright if I go on to the second page? Well, actually, I can probably just do this. Okay. Okay. Now, difference of squares is something called, or something referred to as a special form. Now, what does difference mean to y'all? Subtraction, okay. And what are some squares that y'all know? Just, what's a square? What's an example of a square? Number. Okay, 4 is a square number, right? Because it's 2 times 2. What are some other square numbers?
10?
25 is one.
Oh.
It's got to be the result of a number times itself, you know?
I got you.
Yeah. 16 is one. 36 is 6 times 6, so that's a square number. Or, well, it's a perfect square, I guess we'd say. Okay. So, what about x squared? Would you call that a square?
Yeah.
Yeah, I mean, it's x times x, just because it's a variable and not, like a number, doesn't mean x squared isn't a square. It is. Okay. So, with the difference of squares, if you have two square expressions, whether they be numbers or variable, expressions, as long as they're squares, and there is a minus sign in between them, there is a very easy way to find out what factors it becomes. So let's say, that you have something of the form a squared minus b squared. Without really doing all that much work, you can say for certain that that is going to decompose into two factors. A minus b and a plus b. And, that might look really weird right now, but you'll get it, and you'll be thankful that you know this. Okay. So, this right here is the difference of two squares, right? You can tell because there's two squares and there's a minus sign in between them. So you're going to be seeing what a squared and b squared are. Take a squared and square root it to find out what a is. Do the same with the b squared. And then just set up two factors, a minus b and a plus b. You know, once you find out what a and b are, just one of the factors is a minus b, one of the factors is a plus b. One's a plus, one's a minus. Okay. And the more that you do this, the easier it'll be. Which I guess sort of tends to be how it is. Okay, so let's just look at example 1. Is example 1 a difference of two squares? Is that two square things with a minus sign in between them? Is x squared a square? Okay, it is. Is 100 a square? Yeah, it's 10 times 10. So this is a difference of two squares. X squared is a square, 100 is a square, you got your minus sign in between them. Take the square root of your first thing. What's the square root of x squared? X, okay, right. Because a square root, all a square root does is undoes a square, so x is what your is the a. It's what your factors are going to start with. Okay, take the square root of 100. That's what your factors should end with. What is the square root of 100? 10. One sign is a plus, one sign is a minus. It doesn't matter which one goes, it doesn't matter if you put x minus 10 first or x plus 10 first, as long as you have both of them. But yeah, x squared minus 100, that factors into x plus 10 and x minus 10. And this is something that you can do yeah. You might notice that there's no x term on here, so there aren't a lot of people who really like to think of it this way, but you could think of it as trying to find two numbers that multiply to negative 100 and add up to 0, since there's no x term, there's no b. It's like having the number you're trying to get them to add up to be 0. But maybe it's just easier to remember. Take the square root of the first thing, take the square root of the second thing, bam, 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 bam. One gets a plus, one gets a minus. Okay, is example 2 a difference of two squares? Okay. What is the square root of 64x squared? 8. Right, so the square root of 64 is 8. And because of the x squared, you're taking that square root of that as well, it's going to be 8x. So 8x is what both of your factors are going to start with. Okay, what's the square root of 9? 3. Okay, so that should go at the back of your factors. 1 gets a plus, 1 gets a minus. Or 1 gets a plus, 1 gets a minus. Okay. Is example 3 a difference of two squares?
Yes.
Okay, right, 49 is a square, x squared, the x squared that's also part of that is a square, and so is 81 and y squared. Okay. So this whole thing is a square, and so is this whole thing. What is the square root of 49x squared?
7x.
Right, the 49 is going to give you 7, and the x squared is going to give you x when you take the square root. So that should go in front of each of the two factors. What about 81y squared? What will the square root of that be?
9.
9y. So 9y. 1 gets a plus, 1 gets a minus.
Alright, Mr. K, this isn't too bad.
Yeah. Is example 4 a difference of two squares?
Yes.
Is it?
No.
Oh,
No, why not?
wait, why not?
Because there's an addition sign and not subtraction.
Yeah. Not a difference of two squares.
So when it's not a difference, we don't do anything?
There's nothing you can do for a sum of two squares. Okay. All right, see, 3 of the remaining ones are differences of two squares. Is y squared minus 1 a difference of two squares? Yeah, okay. Let's see, to find out what our term should start with, what's the square root of y squared? Just a plain y. So that goes in the front of each of these. What's the square root of 1? 1. Yeah. One of the factors gets a plus, the other one gets a minus. Make sure that make sure that that's the way it is. Make sure you don't write two pluses or two minuses or anything like that. Okay, is example 6 a difference of two squares? No, because of that plus sign. If you want, you could say that it was prime, but yeah, I mean, if you want, you can say it's prime. But specifically, it is not a difference of two squares, like all the others here. Okay, this one's gonna make sure that you understand your, exponent rules. Is this a difference of two squares? Okay. What is the square root of x to the fourth? What can you multiply by itself to get x to the fourth?
X times X times X times X.
Right, but that's multiplying four things together. What can you multiply two of the same thing together? X squared. As in x squared times x squared equals x to the fourth? Okay, so the square root of x to the fourth is x squared. That's what your factor should start with. X squared and x squared. Now about the square root of, well, you all know what the square root of 100 is. It's 10. Sure, okay, so 10 will be a part of this. But what is the square root of y to the sixth? What can you multiply by itself? Yes. It's y to the third times y to the third that is going to give you y to the sixth. So it's 10y to the third in the back of each of these factors. One gets a plus, one gets a minus. Cool, very good, very good. And then the last of these. This one actually isn't very yeah. First of all, is this a difference of two squares?
Yes.
Yeah, two square expressions, minus sign in between. Good to go. What is the square root of 36y squared?
6y.
Yeah, 6 from the 36, 6 from taking the square root of 36, and y from taking the square root of y squared. So 6y should start each of your factors. And what about the square root of 49z squared?
-7z.
Yes. Or just, yeah. One of them would be minus 7z, the other one would be plus 7z, but it's 7z that is, at the back of each factor. Oh. Jeez. Okay. Oh. Okay. Oh, we're not making bad time. Okay, now these last 7, they're prefaced by the instructions to factor completely. And for that, you can use any of the techniques we've learned so far. Factoring out greatest common factors, factoring trinomials of the form, ax squared plus bx plus c, using the difference of two squares. But I'll tell you that you should always check to see if you can factor out a greatest common factor. Because factoring out a greatest common factor out of an expression like this, that's going to make all the numbers inside lower. And the lower the numbers are on the inside, the easier they are going to be to work with. So it's not even, that much trouble to just check, when a mathematical expression first enters your sight, just ask yourself real quick, is there anything I can factor out of all these terms? Okay. As opposed to trying to deal with it exactly as it looks and as it's presented. Just ask yourself, is there anything I can factor out of all of these terms? Certainly, yeah, for the numbers you can factor out a 3. That is the greatest common factor for the numbers. Right, and for the variables you can always factor out the lowest power that appears. So your greatest common factor here that you're going to want to factor out is 3x. And if you do that, that's going to make the rest of this a lot easier. Just pretend you're dividing each of these by 3x. That'll tell you what you have left on the inside. So, you had 9x cubed, but you took out a 3x. What's that going to leave you with?
3x squared.
Yeah. 9 divided by 3 is 3, and x cubed divided by an x is going to be x squared. Hold on, let me do this in... yeah, 3x squared. Plus 5x, that's correct. Yeah, 15 divided by 3 is 5. X squared over x is x.
Plus 2.
Right. 6x divided by 3x is plus 2. Okay. It's a little better, instead of 19, 15, and 6, now we have, 3, 5, and 2. Those are sort of slightly easier numbers to work with. More importantly, instead of being like an x cubed kind of expression, it looks like once we factor that x out to the front, the inside becomes this sort of quadratic. And we know how to deal with quadratics. Okay. we're going to focus on this 3x squared plus 5x plus 2 for now. But just don't forget that there's that greatest common factor of 3x still sort of out in the front. So we're just going to deal with this temporarily. In fact, I'm going to say don't forget this. Don't forget about this. But we're just going to deal with 3x squared plus 5x plus 2 for now. Now this is one of those slide and divide trinomials, it looks like. If you slide that 3 to the back, it's going to give you x squared plus 5x plus 6. This is getting kind of crowded. Two numbers that add up to 6, sorry, that multiply to 6 but add up to 5. 2 and 3, plus 2 and plus 3. Except this was a slide and divide, so we got to now divide by 3. Plus 2 over 3 does not reduce, but plus 3 over 3 does reduce. It reduces to plus 1. So what two factors does 3x squared plus 5x plus 2 become? Right, one of the factors is x plus 1. I don't even know where to write this. One of the factors is x plus 1. What's the other factor? Okay, and that's from this, 3x plus 2. And what was in the front of this all that we said we wouldn't forget about? The 3x that we factored out in the very beginning. So really, it is just a slide and divide trinomial with the extra step of having to factor out that greatest common factor in the beginning. Is there anything that you can factor out of example 2?
No.
Yeah, there's not much, but there is something, and that is 2, because all these numbers, 6, 26, and 20, are even. But that's about all that you can do. But still, that's gonna take each number and make it half of what it is, so that's gonna be helpful. So if we factor out a 2, instead of 6x squared, we're gonna have 3x squared. Instead of 26x, we're gonna have minus 13x. And instead of minus 20, we're gonna have minus 10. And that 2 that we factored out is gonna be in the front of it all. Okay. Okay, now the 3x squared minus 13x minus 10 that remains is, we're going to deal with that as a sort of slide and divide trinomial. But we'll just make ourselves a little note not to forget this 2 that's in front. Because the 2, it's a part of this expression too. It can't just disappear. But we're just going to focus on the trinomial for now. So 3x squared minus 13x minus 10, we're going to slide that 3 that it begins with. Oh, that looks like a y, it's an x. We're going to take that 3 and slide it to the back. Okay, that's going to give us the slightly simpler polynomial x squared minus 13x minus 30. Okay, two numbers that multiply to negative 30, but add up to negative 13. This is also another tricky one, actually, because there are, two numbers that you might be inclined to gravitate towards, but they're not the right ones. What? Yeah. When I first started writing this, I was thinking, okay, well, that's obviously 10 and negative 10 and negative 3, but that doesn't actually. That will multiply to positive 30 instead. So the real numbers are negative 15 and positive 2. Okay, and we're going to divide by that original 3 that we slid. Negative 2 over 3 does not reduce, but does negative 15 over 3? Yeah, negative 5. Okay, so just for this trinomial 3x squared minus 13x minus 10, what are the two factors that it becomes? X minus 5 is one of them.
And then 3x plus 2?
Yes. So one of the factors, I don't know where to write this, is x minus 5, and 3x plus 2 is your other one. The one that didn't reduce, you know.
And then
And-
drop down to 2?
Right. There. Don't forget this 2 that we factored out in the very beginning. That's got to be a part of the expression 2. So that is the completely factored form. Who the is this? Okay. Now, 3t squared minus 192, that's not immediately recognizable as anything, really. You might have some sense of what this could become. Is there any greatest common factor? 3? Let's see. Certainly 3, you can take 3 out of 3. Yeah, taking 3 out of 3t squared gives you t squared, and taking 3 out of, as a factor out of 192 gives you minus 64. Okay, that's looking a little better. What does this look like? Yeah, a difference of 2 squares, just like we were doing up here. I mean, I see 2 squares. I see a subtraction sign in between them. Looks like a difference of 2 squares to me. So this is going to become 2 factors. Right. Mm-hmm. Yeah, just take the square root of t squared and 64. You get t and 8.
And then you just drop down to 3, right?
Yeah. One of them gets a plus, one of them gets a minus.
But you know what's driving me crazy? That this is the answer. I want to distribute. I want it to be like 3t plus, I don't know why I
Like,
wanna do that.
yeah, if you did that, it would just become this.
Yeah, I know.
So there are times in math where you do want to, expand something as big as possible. But there are benefits to factoring to, writing it like a bunch of little things you're multiplying together. There are benefits to each. Okay, 4 more. Maybe we'll leave early. I don't know. I don't know that that's ever happened. Okay. Now there is a number that you can factor out of example 4. What is that number? 3. Right, and I mean, I didn't say this super explicitly, like it was more like an offhand comment, but you want, generally speaking, you want your leading term to be, like the stuff that you're left with, you want it to be positive. So if something you're factoring starts off with a negative, you want to factor that negative out as part of the greatest common factor. So your greatest common factor here is, we're going to use negative 3. Because if we just use 3, we're going to be left with this weird negative x squared thing. Whereas if we factor out the negative sign as part of the greatest common factor, we don't have to be left with that. So if we factor out a negative 3, what are we going to have left?
X squared.
Right, just x squared. And what about minus 3x divided by negative 3? Plus x, the 3's cancel out, and the minuses cancel out too. Minus 6, great. Okay, looks like a perfectly good trinomial to me. Two numbers that multiply to negative 6 and add up to 1.
-2 and 3.
Yeah, right, okay. Negative 2 and 3. Because, they gotta multiply to negative 6, so one has to be positive and one has to be negative. They add up to 1, so that means the positive one has a greater magnitude, but just a little. Yeah. So plus 3 and minus 2. And this is not, this is the trinomial that we're working with, x squared plus x minus 6, that's not one of those slide and divide polynomials. So we can just use these two numbers as they are. So one factor is x plus 3. Another factor is x minus 2. And what was in the front that we factored out? And negative 3. Don't forget about it. This one's kind of a weird one. 4 terms. Might not have seen this in a while. But this is going to be, well, first of all, as you should always be asking yourself, is there anything that you can factor out of all these terms? Oh yeah, right, 6. And then so the first thing we're going to do is we're going to factor out the 6. And then what are we going to be left with if we factor out a 6? Okay, x squared.
Plus 5x.
Okay, plus 5x, that's the second term.
Minus 3x.
Okay. And 90 divided by 6 is going to be, or negative 90 divided by 6 is going to be 15, or minus 15.
Thanks for saving our brains, Mr. K.
I mean, there are just some quotients that are clearer than others.
Yeah, I guess it's, the more you and math become a thing,
Yeah.
your brain kind of just follows.
Okay, so, still 4 terms. But we did factor this 6 out, so numbers are a lot lower. The coefficients are a lot lower. But there are 4 terms. I'm going to factor by grouping. Alright, well,
You don't combine like terms?
you honestly could. You could say minus 5x minus 13x. So like the intended thing that this is supposed to be teaching is factoring by grouping, which is sort of why they're separate terms. You could combine them, and then that forms like a regular trinomial. That's just going to form the regular trinomial x squared plus 2x minus 15.
Right.
And you can do that.
Okay.
Yeah, that'll work in this case. That wouldn't work if, for example, what if this was like x cubed and this was x squared? Then they aren't like terms. Because sometimes that happens. But, yeah, you can go ahead and combine the 5x and the minus 3x if you really want to sidestep the spirit of the problem. I'm just gonna do it by grouping though. First telling myself not to forget the 6. As I go ahead and deal with x squared plus 5x minus 3x minus 15.
Is this the
This is where you could, yeah.
Okay, because I did at the beginning, and so that's why.
Oh, yeah, you can combine these two right away. 30 minus 18 is 12, factor a 6 out of that, that'll be 2, right? Or you factor a 6 out first, 5 and negative 3, that's also a 2. Doesn't actually, you know. Me, though, I am going to factor by grouping. Out of here, I'll factor out a x, giving me an x plus 5. And out of this pair, I'll factor out a negative 3, also leaving me with an x plus 5. That tells me some things. One of my factors is this repeated factor of x plus 5. That's one of my factors. My other factor is the stuff in front, this x minus 3. And don't forget about this 6. So even if you did it the other way, where you combine like terms, you should still end up with this. So this is factoring by grouping. If you did it this way. Okay. 36y squared minus 81. Is there anything you can factor out of here? Out of example 6, out of both terms there? You might be surprised.
9, yeah, 9.
9 fits into 36, and 9 fits into 81. So we'll factor out a 9.
So 4y.
Mm-hmm.
9.
Minus 9.
Minus 9.
Yeah. Okay, now, I mean, technically, even as it was first presented, even when it was 36y squared minus 81, it was already a difference of 2 squares. You know, 36y squared is a square, 81 is a square, but it's not fully factored. Now it is. So is 4y squared minus 9 a difference of 2 squares?
Yes.
Right, 4y squared is a square, 9 is a square. So 2 factors here. What's the square root of 4y squared? 2y. What about, okay, so that should go in the beginning of both of our factors, right? That this is going to end up as. What about the square root of 9? 3, okay. And should they both get minus signs? One of them gets a minus, one of them gets a plus. Doesn't matter which, as long as they're, you know, as long as each of them appears once. And don't forget about that 9 in the front. Okay.
Mr. K, you are rolling today.
You're doing great.
Yeah, it's the fever.
So you gotta be
Yeah.
To be like,
What's up?
Sir, are you okay?
she wasn't here, so
Yeah.
she missed that part.
Oh, okay.
She was going to get her.
No, I took some fever reducer. Yeah, it went down to like, I think like last time I checked it was like 100.2.
We said you home.
Down from
We said
higher.
you home immediately if you're at purpose. Goodbye. Bye-bye. And did you throw up? Bye.
Diarrhea? Out the door.
Oh no, you get to come back for 2. You get to have 2 at school. But, bye.
I hope you feel better, Mr. K.
Oh yeah, thanks. Me too. And I hope I don't get any of you guys sick. I don't think I will, but like.
Nice to know that, Mr. K.
Okay, what can we factor out of this last problem here?
Negative 5x.
Yeah, specifically a negative 5 because if there is a chance to factor out a negative, we want to take it. Okay, so if we factor out a negative 5, oh, not just a negative 5, right? Negative 5x, okay. If we factor out a negative 5x out of each term, we're going to have 3 terms. What 3 terms are we going to have?
X squared
Okay, a plain x squared.
and
Minus
X squared.
This middle term will be plus because you got minus 5 being divided by minus 5.
So it'd
And-
be plus X.
Right, just a plain plus x. And 60 divided by negative 5,
It's negative 12.
negative 12, and x and over x cancel each other out.
Right.
Yeah. So you just end up with x squared plus x minus 12. That's that's a pretty regular trinomial there. What two numbers can you think of that multiply to negative 12 but add up to 1? Now they multiply to a negative number, so one of them's positive, one of them's negative.
Negative 12?
They got to be pretty close together because they add up to 1.
-3 + 4.
Yeah. -3 and +4. This is not a slide and divide polynomial, so it's just these numbers. Okay. X minus 3 is a factor. X plus 4 is your other factor.
And you got divided by -5.
Yeah, you don't have to divide it by -5x, but you have to remember that the greatest common factor is there.
Because I didn't slide, right?
What's up?
You don't do it by the -5 because I didn't slide.
Right.
Okay.
You factored it out, and then it just becomes a regular.
Okay.
Yeah. So the GCF is -5x, and you don't want to forget about it. So this is the fully factored form.
Look at you.